today I would like to talk about the when tech meets nature, and the subtitle is the potential of the ultra-flexible, very thin electronic systems for natures, more specifically the living animals, including human beings or insects. In this talk, I will show some insect movies and photos. I hope that you are good at watching such a movie videos. So in the field of the flexible electronics, many researchers are focusing on these kind of the very conformable wearable electronic systems. The major purpose of such a wearable electronic system is for the sensors applications. There's such a very thin sensors, monitoring the vital signals continuously for long term directly onto the human skins or clothes. So the power sources is always bottleneck toward the long-term operation of these devices. So our group is focusing on developing the energy harvesting devices, more specifically the solar cells, using the organic or perovskite materials. And then the key features are shown here. The first one is a very flexible and very lightweight. And then the next one is a very thin properties. Our solar cells have the total thickness of just 3 micrometers, including both substrates and passivation layers. So such a very thin properties enables the very lightweight properties and flexibilities. And then such a very thin properties can enable the very good robustness for the bending stresses. Even though we trample the devices of our solar cells, our solar cells can operate almost normally. And then recently we generated a large power per unit weight up to the 40 watt per gram under the outdoor sunlight conditions. And then the potential application, one of the very important application is for the sensors, wearable sensors. So we integrated the solar cells and the wearable sensors directly onto the very thin substrate. Then we attach such a sensor systems directly onto the human bodies. In these cases, we attach the sensors on the human fingers. And then the right side, there is a solar cells. The almost center side, there is a sensors, the organic electrochemical based sensors. And then we monitor the ECG signals using such a self-powered electronic device systems. So maybe this can be concluded that the solar cells, very thin solar cells, can supply power to the conformal sensors. And then the important another aspect is printing technologies. So we can use printing technologies to make the large area or high throughput devices, solar cells and other devices. And so we recently fabricated fully solution processed the self-powered sensors. In this study, we developed the solar cells, photo detectors, and the light emitting diodes, 3 different photo devices simultaneously using the solution processes, printing processes. And then we monitor the heartbeat rate directly onto the human fingers, as shown here. So then I would like to move to the next topics. Recently we are focusing on the soft robot applications. Then we consider the living animals, living insect as a soft robot actuators. And so we try to control the insect locomotion, the walking, turn right, turn left. These activities can be controlled by the electronic devices. So we developed a rechargeable cyborg insect systems using our solar cells. The solar cells are attached onto the abdominal surfaces, and the other components such as the batteries or wireless motion control systems are integrated onto the thorax, near the head side. The important finding is that enough thin film properties can secure the basic motion ability of such a small insects, which I show these three movie clips. The left shows no films attached. Center, 5 micron film attached. The right one shows 20 micron film attached to the abdominal surfaces of the insects. And then we can see the clear differences. The upside down attempt was conducted. Of course, if there is no film, they can quickly succeed. 5 micron, it takes time, but finally they succeed. 20 micron, they couldn't succeed such an upside down attempts, the self-writing attempts. So for us, for human beings, we cannot recognize the differences between 5 micrometers and 20 micrometers. Both are enough thin for us, but they are not. Because they are the small animals, the difference is very, very important for them. So as I mentioned in the earlier slides, our solar cells thickness is just 3 to 4 micrometers. So when the solar cells are attached to the human insect bodies, they succeed this kind of upside down attempts as shown here. So this is very important point that why we need thin, lightweight electronic systems for small robot systems or living animal systems. And then we did this kind of a demonstration, the recharging of the locomotions, wireless locomotions of the cyborg insects. If the battery is empty, of course we cannot control the motion of the insects at all. So after that, we recharge the batteries using the solar cells attached onto the insect abdominal surfaces. Then after that, we could control the insects, the motions. When we push the turn right button, actually the insects turn right, as shown in these movie clips. So we have the collaboration with the Singapore professors. Our target application should be the rescue task during the disasters, such as big earthquake, finding the people under the rubble. This is our main target, one of the biggest target applications. And then recently we focus on the other potentials of using the flexible electronic device systems. And the previous slide, where the locomotion control was conducted by the inserted the wires. But in these cases, we just attach the film-based electronic systems onto the abdominal surfaces, as shown here, to control the right side, left side, or go straight, and so on. So the important technology is how to make a very good conformability between the insect bodies and the electronics. So we developed the very good materials and strategy to make a conformable contact between the electrodes, the films, and then devices. Okay, then we confirmed that such a thin film-based electronics can actually control the turn right or turn left of the insects, as shown here. And then furthermore, when we apply the both turn right and turn left button, we can accelerate the walking ability of the insects, as shown here. The insects can quickly traverse the obstacles with the stimulated signals. Okay, then we are now considering how to integrate these very, very thin flexible electronic systems. So we are now developing the conductive bonding technologies between the one electronics and the other electronics. So in this slide, we show the devices. One is the solar cells, the other is LEDs, integrated conformally without any adhesives. So we can secure the total flexibility using such a no-adhesive bonding technologies. And then we prepare the two different films on the different substrate, and we apply the little bit special plasma treatment processes to make the perfect bondage interfaces between the one gold layers and the other gold layers. So we achieved the metal-metal bonding technologies. So then we could do these kind of demonstrations. The top side, there is a solar cells. The right side, there is LEDs. When we apply the sunlight illumination to the solar cells, OLEDs turn on. And then we make the compressed stress to the whole systems, both the wires and the LED devices. Even after such a processes, our whole integrated systems can operate almost normally, perfectly operated. So because we don't use any adhesives, we can secure the thinness of the whole systems. So maybe using such a technologies, we can consider for the more complex integrated device systems with very thin natures. So this is a summary of my talk. So maybe we are focusing on the ultra flexible electronic systems. So such electronic devices is unconscious technology for a visible impact on the life and the nature, and they can seamlessly integrate the intelligence for a better QoL and a greener Earth. So I would like to thank all the collaborators in Japan and all over the world. Thank you very much for your kind attention.